All right, so our warm-up problem, there's kind of two options, at least two options for how you can do it. One would be to graph the line. We're going to be looking at equations and graphs of lines today. But my challenge to you was find a way to do this without actually graphing the line and just use the numbers. That would be the algebraic method. If you didn't do it algebraically, if you did it by graphing, I want you to pay attention because what I'm going to show you here is a technique that we'll be using for other situations this year. Okay, so I've got my equation, and I've got a point that's on the graph of that equation, but I've only got half of the point. All they gave me was the x value for this point. Does anybody know how I could use the equation to figure out the y value for that point? How could we do that? How did you do it? Yeah, so you could take this x value, this -2, you could put it into this equation, and then you could solve the equation for y. And that would tell you the y value that goes here. So my equation was y equals 1/2 x minus 3. I could take this x value here and stick it into the equation where x goes, and then solve that resulting equation and get y by itself. Y is already by itself, I just need to simplify over here. 1/2 times -2 is -1, and -1 minus 3 is -4. So my y value here would be -4. So in B, it's the opposite. They gave us a y value here, and they're asking us to find the x value for that. Could we do the same method that we just did? No? We're going to have to change it. You're right. We can't do exactly the same thing. We're going to have to change one small thing about what we just did. What are we going to do differently for this one? This is going to go in for the y instead of for the x. So we can still use our equation. Our equation was y equals 1/2 x minus 3. Except this time we're going to have to plug that -1 in place of the y. And then we solve this. Now this one's going to take us some actual algebra steps to solve, but you guys know how to solve an equation like this, right? Get x by itself. What would you do first? Probably get rid of that -3, right? Plus 3 both sides. That gets us 2 equals 1/2 x. Do y'all know how to get rid of a fraction that's multiplying by x? Oh, did you just say that R word? Nice. Do you remember what it was? Reciprocal. You guys know what a reciprocal is? How do you find the reciprocal of a fraction? If I got a fraction like this, how do I find its reciprocal? Just flip it. Top becomes the bottom, bottom becomes the top. So if I want to get rid of a fraction that's multiplying, I can multiply by the reciprocal fraction. It would be 2/1. I got to do it on both sides because that's the rule of algebra. But when you do this, these 2's would cancel and these 1's would cancel, and you'd just be left with x. So when you multiply by a reciprocal, all the parts for your fractions are going to cancel, and it's going to go away. 2/1 times 2 is 4. So the x coordinate ended up being 4 for that one. How many people, when you got to the y-intercept, looked at that equation and remembered which of these numbers in the equation is the y-intercept? Do you guys remember that? There's two important pieces of information in the equation of a line. There's a slope and a y-intercept. Do you remember which is which? So in this one, the y-intercept would be -3. So we didn't have to do any fancy math to get that. You should recognize that that's our y-intercept at -3. The x-intercept does not appear in the equation. How would we find the x-intercept? Well, we're going to have to take this y value of 0 and plug it into the equation and solve. And I'll leave that last step to you. So the work would look a lot like this, except we'd put a 0 in place of the y here instead. Okay. You guys feeling all right about that? Any questions about the assignment before we go on? Just want to give you another opportunity. I don't know when the bell rings.